Hello, myself Rahul Khandagle. I am a mechanical graduate having 20 plus experience in HVAC industry working as a freelance engineer. In this session, we are going to talk about district cooling system, my experience with DCS, what is DCS and why DCS. My experience with DCS, conceptualization and master planning of district cooling system, tender specification drawings and BOQ, budgetary block cost estimate, pre-qualification of the bidders, pre-bid meetings, response to pre-bid queries and addendums, technical evaluation of the bid documents, review and approval of contractors' documents and drawings, and factory inspection of chillers and cooling. What is DCS? Today we are adopting the concept of building green smart cities, which are having mixed occupancy. When it comes to air conditioning, DCS seems to be the most probable option. DCS is basically a centralized chill water plants distributing chill water through insulated chill water pipes buried or rooted in below ground utility corridors to connect various buildings in the city. Why DCS? Heavy cooling load diversity on installed chiller capacity when further combined with thermal and storage system. Mixed occupancy such as commercial, residential, retail, hotels and restaurants, institution, hospital, etc. doesn't peak at the same time. Series counterflow arrangement of chillers increases the temperature rise delta T of the chill water, thus reducing the demand flow rate. Secondary and tertiary pump sizing, distribution network pipes and fitting sizes, wall sizes, etc. Why DCS? Increased combined efficiency due to series counterflow arrangement. HT chillers, by adopting HT chillers, the voltage transmission and step down losses are reduced. Reduce treated STP water requirements for the cooling towers. Why DCS? Reduce capital cost and operational cost due to reduce installed chiller capacity and its related system components. Reduce electrical contract demand and sizing of transformers. Reduce maintenance costs. The developers or the builders is relieved of the maintenance issues of the chiller end. Standardization of equipment and its spare parts. Skilled operation and maintenance staff at DCS location only. Why DCS? Space saving. Due to centralized plant location, the space occupied by the chillers, cooling towers, pumps, and its related mechanical and electrical components at the individual building end is reduced. Space is only required for energy transfer stations with tertiary pumps and expansion tanks in the basement of the building. The space required for the DCS plants will be very less when compared to the combined space requirement for the central plants at individual building locations. Why DCS? Eliminates noise of the chillers, pumps, and cooling towers at the building end. The central plants are located away from the human occupied areas. Modular expansion. The development in the smart cities usually spans over a period of 15 to 20 years. Buildings comes up in the phase-wise manner as per priority planning. The DCS plants in this case can be built in a modular fashion, thus reducing the initial dead capital and the operating cost. Here provision for future expansions can be made in advance. Why DCS? Heavy reliability. When combined with thermal energy storage, it can feed the low loads without operation of the chillers, thus eliminating the inefficient operation of the chillers. The thermal energy storage can act as a standby in case of failure of any chiller unit. The distribution network can be so designed that in case of breakdown in any chill water circuit, the other circuit can at least meet the critical loads. Next session, we will be covering few more chapters on district cooling system. By then, thank you. See you again. For your queries and suggestions, I am available at rjk.hvac2020 @gmail.com.